Look up at the night sky. What do you really see? The twinkling stars, the sweeping arc of the Milky Way. Here's the truth. Much of what's out there is hiding in plain sight. The universe is a master of disguise, weaving illusions so convincing, even our most advanced telescopes are fooled. Light bends around invisible cosmic giants. Stars that died millions of years ago still flicker in our skies, and entire galaxies cloak themselves behind curtains of dark matter. Today, we're pulling back the veil on these cosmic tricks, revealing how space plays the ultimate game of hide and seek. From the ghostly fingerprints of gravitational lensing to the eerie remnants of long-vanished galaxies, you're about to witness the universe's greatest sleight of hand. By the time we're done, you'll never look at the night sky the same way again, because once you see the secrets it's hiding, there's no unseeing them. Every star you see at night is a message from the past, a glowing time capsule traveling across space. Take the bright star Betelgeuse in Orion. What you're seeing tonight is light that left that star 600 years ago. If Betelgeuse exploded last week, we wouldn't know until the light of that cataclysm finally reaches Earth centuries from now. This strange trick of light means our night sky isn't just a map of space, but a patchwork of different eras. When you spot the Andromeda Galaxy with the naked eye, you're glimpsing light that began its journey 2.5 million years ago, before humans even walked the Earth. Telescopes push this effect to extremes. The Hubble Deep Field Image, for instance, captures galaxies so distant their light has been traveling for over 13 billion years. We're not just observing space, we're peering directly into the universe's childhood, watching ancient structures form in real time. This time delay creates surreal overlaps where newborn stars in one part of the sky shine alongside the last light of long-dead giants in another. It's as if the cosmos folded its history like a book, letting us flip through chapters just by pointing our telescopes in different directions. Gravity doesn't just hold the universe together, it twists it into optical illusions we're only beginning to unravel. Picture a galaxy so massive it acts like a cosmic magnifying glass, warping the fabric of space around it until light from objects behind it bends into strange, stretched arcs. This is gravitational lensing in action, where distant galaxies appear as smeared rainbows or eerie rings around the foreground galaxy, causing the distortion. Einstein's theory of relativity predicted this phenomenon over a century ago, but the most stunning proof came decades later when astronomers spotted perfect halos of light nicknamed Einstein rings, celestial bullseyes where a hidden galaxy's light gets bent into a circle by an invisible cosmic heavyweight. These natural telescopes reveal galaxies so far away their light has traveled nearly the entire age of the universe to reach us. But the real magic lies in what lensing exposes that we can't see at all. When light bends more than the visible matter accounts for, it betrays the presence of dark matter, the universe's hidden scaffolding. Entire clusters of galaxies act as lenses far stronger than they should, proving that something invisible is contributing to the gravitational tug. It's as if the cosmos left fingerprints in the warped light, giving us clues to decode its deepest secrets. From quadruple images of a single supernova to ghostly mirages of galaxies that shouldn't be visible, gravitational lensing turns the universe into a hall of mirrors, one where every reflection holds a new revelation. Think of the universe as a spider's web. What you see shimmering in the sunlight is just a fraction of the structure. The real strength lies in the nearly invisible silk threads holding everything together. That's dark matter, the unseen architecture keeping galaxies from flying apart. Take our Milky Way, it spins so fast that stars on its outer edges should have been flung into the void long ago. Yet they cling to the galaxy as if gripped by some unseen force. The math is undeniable. There's 5 times more matter tugging on those stars than all the visible gas, dust, and stars combined. But here's the twist: no telescope, no matter how advanced, can spot this missing material. It doesn't glow like stars or cast shadows like planets. It doesn't even bump into regular matter the way you'd expect. When two galaxy clusters collide, astronomers have watched normal matter, glowing hot gas, slow down like cars in a traffic jam, while the invisible mass barrels right through, leaving only gravitational ripples in its wake. The hunt for dark matter's identity has led scientists down two fascinating paths. One camp searches for exotic particles that barely interact with light or matter, theorized entities with names like WIMP or actions. Imagine tossing a handful of snowflakes through a chain-link fence. Most pass right through, but every so often one sticks. That's how detectors buried deep underground try to catch these elusive particles, waiting years for a single flicker of evidence. Meanwhile, another group questions whether we've misunderstood gravity itself. Could dark matter be an illusion, a mirage created by the rules of physics working differently on cosmic scales? It's like realizing the blueprints for a bridge were wrong all along, not because the materials are missing, but because we misread how weight distributes across its spans. Yet whether it's unseen particles or rewritten physics, the effects are everywhere. Look at the Bullet Cluster, where two galaxies collided and left their dark matter skeletons exposed through gravitational lensing. Or the eerie dark galaxies, spotted in surveys, massive clumps of gravity with almost no stars to account for them. Even stranger are the vast cosmic filaments, threads of dark matter stretching billions of light years, guiding galaxies into their places like beads on a string. Without this hidden framework, the universe as we know it wouldn't exist. Stars would never have clustered into galaxies. Galaxies would never have formed the intricate webs we see today. It's humbling to realize we're walking through a house built by ghosts, surrounded by walls we can't touch or see, only feel through their unshakable pull on everything around us. If dark matter is the invisible scaffold holding galaxies together, dark energy is the mysterious force tearing the cosmic fabric apart. Picture the universe as an inflating balloon, not just getting bigger but accelerating faster with each passing moment. In the late 1990s, astronomers made a shocking discovery. By measuring distant supernova, they found that the expansion of the universe wasn't slowing down as expected. Instead, it was speeding up, as if some unseen hand was pressing harder on the cosmic gas pedal. This bizarre acceleration defied everything scientists thought they knew about gravity. The culprit, dark energy, an enigmatic force making up nearly 70% of the universe's total energy. Unlike dark matter, which pulls things together with gravity, dark energy pushes, stretching space itself apart. Some theories suggest it could be an intrinsic property of empty space, a sort of anti-gravity woven into the fabric of reality. Others propose a new, undiscovered energy field that permeates the cosmos, growing stronger as the universe expands. But one thing is certain: its effects are irreversible. Every second, more and more galaxies cross an invisible horizon, their light forever lost to us as they're carried away by the relentless expansion. What makes dark energy even stranger is that it wasn't always in control. For billions of years after the Big Bang, gravity dominated, slowing the universe's expansion as matter clumped together. But around 5 billion years ago, dark energy took over, flipping the cosmic script. Now it dictates the universe's fate, a future where galaxies beyond our local group will fade from view, leaving the night sky eerily empty for civilizations billions of years from now. The discovery reshaped cosmology overnight, forcing scientists to rewrite the rules. Before, they assumed a universe that would eventually collapse back in on itself or coast to a gentle stop. Instead, we now face the possibility of a big freeze, where expansion continues forever, pulling matter so far apart that stars can no longer form, and space becomes a cold, dark void. Yet the mystery only deepens the more we look. Recent measurements of the Hubble constant the rate of cosmic expansion don't quite match up, leaving astronomers puzzled. Could dark energy be changing over time? Is it interacting with dark matter in ways we don't yet understand? Or is this yet another cosmic illusion hiding a truth even stranger than we've imagined? One thing's clear, we're still just scratching the surface. Every answer leads to more questions, reminding us how much of the universe remains hidden, vast forces at work beyond our current grasp. Deep in the cosmic shadows, astronomers have stumbled upon celestial ghosts, galaxies so faint they barely register against the blackness of space. Dragonfly 44 is one such specter, a sprawling galaxy with the mass of our Milky Way but only 1% of its stars. If you could float through its territory, you'd find yourself in a realm of near-total darkness, where sparse stars drift like lonely fireflies in an endless void. These aren't failed galaxies, they're overflowing with unseen mass, their gravity betraying the presence of something far stranger. The mystery lies in the numbers. A typical galaxy's rotation relies on the tug of visible matter, stars, gas, and dust. But in these ghostly systems, the math doesn't add up. There's simply not enough ordinary material to explain how they hold together. Take the Antlia 2 dwarf galaxy, discovered in 2018, hiding right in our cosmic backyard. It's 10,000 times dimmer than it should be for its size, yet it hasn't been torn apart by the Milky Way's gravity. Something invisible is shielding it, acting like an unseen armor. So how do galaxies like these even form? One theory suggests they might be cosmic relics, ancient fragments left over from the early universe, where dark matter clumped together but never gathered enough gas to ignite abundant star formation. Imagine building a skyscraper's steel frame but never adding the glass or walls. Another possibility is that these ghosts are the stripped remains of once normal galaxies, their stars ripped away by collisions, leaving only their dark matter skeletons behind. The implications are profound. If dark matter can sculpt entire galaxies with barely any stars, it means our current models of galactic birth are missing critical pieces. Every ghost galaxy discovered forces astronomers to reconsider the rules. Perhaps dark matter isn't just an invisible glue holding galaxies together. Maybe it's the primary architect shaping cosmic structures long before stars get a say. And the creepiest part, we've likely only spotted the tip of the iceberg. Surveys estimate there could be hundreds of these phantoms lurking undetected around the Milky Way alone, each one a silent testament to how much of the universe's true structure remains hidden in plain sight. They're cosmic echoes whispering that what we see with our telescopes is just a fraction of the story, a glittering facade draped over a far stranger, darker reality. Black holes are the universe's greatest magicians, masters of deception that hide in plain sight. Though they swallow light whole, leaving no trace of their presence, they betray themselves in the chaos they create. Picture a star whipping around an invisible point at breakneck speeds, its path tracing an elliptical dance around nothingness. That's how astronomers first confirmed Cygnus X1, a black hole nearly 6,000 light-years away, tugging a companion star like an unseen puppeteer. But the real show begins when matter spirals too close. Superheated gas forms a glowing whirlpool called an accretion disk, reaching temperatures of millions of degrees, a dead giveaway that something monstrous lurks at the center. Then there's the lensing effect, where black holes twist spacetime into a funhouse mirror. Light from background stars bends around them, creating eerie duplicates or stretched arcs like a cosmic hall of mirrors. In 2019, the Event Horizon Telescope captured this distortion firsthand, revealing the shadow of the supermassive black hole at the heart of galaxy M87, a dark silhouette ringed by a fiery halo of warped light. But perhaps the most mind-bending trick is gravitational waves, ripples in spacetime itself. When two black holes collide, they send out tremors detectable across billions of light years, like a silent drumbeat echoing through the cosmos. Yet the ultimate illusion lies just beyond the event horizon, a boundary where time and space switch roles, cross it, and the pull becomes inescapable, stretching matter into spaghetti, thin strands in a process called spaghettification. Even stranger to an outside observer, an object falling in would appear to freeze at the horizon, its light redshifted into oblivion as if time itself had stopped. The black hole's sheer gravity warps reality so completely that the laws of physics as we know them cease to apply. What's truly unsettling is how common these cosmic traps might be. Astronomers now suspect nearly every large galaxy cradles a supermassive black hole at its core, with millions more smaller ones lurking in the darkness. Some could even be primordial, born in the chaos of the early universe, long before the first stars flickered to life. They're not just destructive forces, they're sculptors, shaping galaxies with their gravity, seeding the cosmos with heavy elements when they collide, and possibly even birthing new universes in their depths. The more we learn, the clearer it becomes. Black holes aren't just objects, they're portals to the unknown, testing the limits of our understanding. Every discovery peels back another layer of their mystery, revealing a universe far stranger, far more inventive in its illusions than we ever dreamed. Imagine two coins spinning in perfect sync, no matter how far apart you separate them. Flipping one instantly determines the state of the other. That's the essence of quantum entanglement, one of the most baffling tricks the universe has up its sleeve. In the subatomic world, particles can become linked in such a way that measuring one instantly affects its partner, even if they're on opposite sides of the galaxy. Einstein famously dismissed this as spooky action at a distance, refusing to believe information could travel faster than light. Yet experiment after experiment has confirmed this eerie connection is real. Take the groundbreaking work of physicist John Bell in the 1960s. His equations proved that entangled particles share a correlation far stronger than classical physics could explain. When researchers finally tested his ideas using photons shot through special crystals, the results were undeniable. Measuring one particle's spin immediately set its entangled twin state with no delay, no matter the distance. It's as if the universe has a hidden communication channel, bypassing the speed of light entirely. But here's where it gets stranger. This entanglement isn't just a party trick for lab experiments, it might weave through the cosmos itself. Some theories suggest the early universe was a hot soup of entangled particles, and as space expanded, those connections stretched across billions of light years. Like invisible threads, they could still link distant galaxies, forming a quantum network that underlies everything we see. Others speculate that space-time itself emerges from these entangled relationships, as if reality is stitched together by a cosmic tapestry of quantum handshakes. The implications are staggering. If entanglement truly connects distant corners of the universe, it could hint at a deeper layer of reality where separation is an illusion. Black holes might use entanglement to preserve information they've swallowed, solving the infamous information paradox. Even time's arrow, the unbreakable rule that disorder always increases, could be influenced by these quantum links as experiments show entangled particles briefly defying thermodynamics. Yet the biggest puzzle remains: how does this spooky action actually work? Some physicists propose undiscovered dimensions where particles exchange hidden signals. Others argue there's no mechanism at all, that the universe simply doesn't operate the way our intuition expects. One radical idea suggests all possible outcomes exist simultaneously until a measurement forces reality to choose, with entangled particles mirroring each other not through communication, but because they're two faces of the same quantum coin. Whatever the answer, entanglement proves the universe loves a good magic act. Just when we think we've figured out the rules, it reveals another layer of mystery, whispering that reality might be far more connected, far more bizarre than we've dared to imagine. Stretch out your hand right now and you're touching it, an invisible sea of radiation left over from the universe's fiery birth. The cosmic microwave background is like the universe's baby photo, a snapshot taken when everything was just 380,000 years old. Back then, the cosmos was a scorching plasma, too hot for atoms to form. But as it expanded and cooled, light finally broke free, streaming outward in every direction. That primordial glow has been traveling for over 13 billion years, stretched by the universe's expansion into faint microwaves that still bathe every cubic inch of space today. What makes this afterglow so extraordinary are its imperfections, tiny temperature variations no stronger than a few millionths of a degree. These microscopic wrinkles are the universe's genetic code, revealing where matter clumped slightly denser, eventually growing into galaxies and galactic clusters. It's as if we're reading cosmic tea leaves, tracing the origins of everything from the Milky Way to the vast cosmic web. But some patterns in this ancient light defy easy explanation. The cold spot, a strangely frigid region spanning nearly 2 billion light-years, puzzles astronomers. Could it be a supervoid, an unimaginably empty stretch of space? Or something far stranger, like a bruise from a collision with another universe? Then there's the eerie alignment known as the axis of evil. For reasons no one understands, large-scale fluctuations in the microwave background seem to line up along a particular orientation, as if the early universe had a preferred direction, a cosmic heresy that challenges our assumption of uniformity. Some theorists propose wild solutions. Perhaps our universe is a bubble floating in a multiverse, or gravity worked differently in those first moments, leaving behind cryptic fingerprints. Yet the most profound revelation lies in what this radiation tells us about the universe's fate. By measuring its subtle polarization, scientists have glimpsed evidence of gravitational waves from the Big Bang itself, ripples that could confirm the universe underwent a mind-boggling growth spurt called inflation, expanding faster than light in its first trillionth of a second. Others study how the microwave background's patterns might hint at dark energy's nature, or whether the universe could eventually collapse back in on itself. Every new map of this ancient light peels back another layer of mystery. It's a time machine pointing backward to our origins and a crystal ball hinting at our destiny, all encoded in microwaves quieter than the static between radio stations. The cosmos is whispering its secrets in this faint glow. We're only just learning how to listen. Our galaxy isn't just drifting aimlessly through space, it's being reeled in by an unseen cosmic fisherman. The Milky Way, along with its neighbors in the local group, is hurtling toward a mysterious point in the constellation Centaurus at over 2 million kilometers per hour. Astronomers call this invisible tug the Great Attractor, a gravitational anomaly so powerful it bends the paths of entire galaxy clusters like rivers flowing toward a hidden waterfall. The strangest part, we can't even see what's pulling us. The culprit hides behind the thick band of stars and dust near our galaxy's core, a region so obscured it's like trying to spot a mountain through a blizzard. Early observations in the 1970s revealed the motion, but only in the 1980s did infrared and radio telescopes pierce the cosmic fog, revealing glimpses of what lies beyond. What they found was the Norma cluster, a dense gathering of galaxies about 250 million light-years away, with enough combined mass to explain some, but not all of the pull. The math still doesn't add up. There's something bigger lurking behind it, a shadowy structure that could rewrite our understanding of cosmic geography. Some theories suggest the Great Attractor might be just the tip of an iceberg, a small part of an even larger superstructure called the Laniakea supercluster. Picture this: galaxies aren't just scattered randomly, they form an enormous web with threads of dark matter guiding them into sprawling continent-like assemblies. Laniakea, meaning immense heaven in Hawaiian, spans 500 million light-years, with the Great Attractor acting as its gravitational center of mass. But even this might not be the full story. Beyond Laniakea, there could be other megastructures exerting their own pull, a cosmic tug of war playing out across billions of light-years. What makes this mystery so compelling is what it reveals about our blind spots. For all our advanced telescopes, nearly half the sky remains difficult to observe because our own galaxy gets in the way. It's like living in a house with one boarded-up window. We know there's a world outside, but we're missing a critical piece of the view. Future missions like space-based infrared observatories aim to map these hidden realms, but for now, the Great Attractor remains a humbling reminder of how much we still don't know. The deeper we look, the clearer it becomes. The universe loves to hide its grandest designs just beyond our line of sight. Whether it's an unfathomably dense knot of galaxies or a previously unknown concentration of dark matter, one thing is certain: the cosmos still holds cards it hasn't shown us. And whatever's out there pulling us toward it is rewriting the map of the universe in real time. Take a single sugar cube's worth of material from a neutron star, and you'd be holding more mass than Mount Everest. These cosmic leftovers are the universe's ultimate sleight of hand, packing the entire core of a dead star into a sphere no wider than a city. Born from the explosive deaths of massive stars, neutron stars crush matter so fiercely that electrons and protons fuse into neutrons, leaving behind a substance denser than anything else in the known universe. If you could stand on their surface, which you absolutely couldn't, the gravity would be 200 billion times stronger than Earth's, flattening you into a thin paste instantly. But the real magic lies in how they warp reality itself. Their gravitational pull is so intense that light can't escape cleanly. It bends around the star like water swirling down a drain. From certain angles, you might see the back of the neutron star's surface curving over the top like a cosmic mirage, as if the star were turning itself inside out. Some even become invisible when viewed head-on, their light bent completely around their equator, leaving only a dark silhouette against space. It's as if these stars have mastered the art of vanishing, using gravity's grip to manipulate what we can and can't see. Then there are the pulsars, neutron stars that spin faster than blender blades, beaming radiation from their magnetic poles. As they rotate, these jets sweep across space like lighthouse beams, flashing toward Earth with metronome precision. The illusion is so convincing that when astronomers first detected these pulses in the 1960s, they nicknamed the signal LGM-1, short for Little Green Men, briefly wondering if they'd stumbled upon an alien transmission. The truth was stranger. Nature had crafted its own cosmic strobe lights, flickering with such regularity they rival atomic clocks for accuracy. Yet even these extreme objects guard deeper secrets. Some pulsars, called magnetars, have magnetic fields so powerful they could strip the data from every credit card on Earth from halfway across the Milky Way. Others exist in binary systems, slowly devouring their companion stars and erupting in X-ray bursts visible across galaxies. And in rare cases, colliding neutron stars create gravitational waves, ripples in space-time detectable billions of light-years away, while forging heavy elements like gold and platinum in their violent embrace. What's truly humbling is how much we still don't understand. The interiors of neutron stars might harbor exotic states of matter, free quarks, hyperons, or even theoretical strange stars made of bizarre particles. Their crusts are thought to be 10 billion times stronger than steel, yet under unimaginable pressure, they could form mountains no taller than a few millimeters. These stellar remnants are more than just celestial curiosities. They're natural laboratories testing the laws of physics under conditions we can't replicate on Earth. Every flash, every warp, every ripple they produce peels back another layer of the universe's grand illusion, revealing how reality bends itself to hide its most extreme creations. The silence of the cosmos isn't just eerie, it's suspicious. With trillions of planets in the Milky Way alone, the math suggests life should have emerged countless times. So why does the universe feel like an empty theater, its seats all vacant despite the show being billions of years old? This is the Fermi Paradox, a puzzle that gnaws at the heart of our cosmic loneliness. One possibility is simple yet unsettling. Advanced civilizations might be everywhere, just expertly concealed. Think of ants crawling through a city park unaware of the skyscrapers towering above, their glass facades reflecting the sky so perfectly they vanish. Could alien societies be hiding in similar blind spots, using technologies we can't even fathom? Some theories suggest they've ditched biology entirely, uploading their minds into quantum supercomputers or swarms of microscopic nanobots. If an entire civilization transitioned into a digital realm, they'd leave no radio signals or Dyson spheres, just faint heat signatures we might mistake for natural phenomena. Others propose they've mastered space-time itself, bending light around their worlds to render them invisible, or slipping into higher dimensions like shadows retreating from a wall. The most chilling idea: they've learned to stay quiet. What if the cosmos is a dark forest where every civilization hides, fearing that any signal might attract predators? Then there's the cosmic zoo hypothesis, the notion that advanced societies observe us from a distance like anthropologists studying an uncontacted tribe, deliberately avoiding interference. It would explain why our telescopes catch no megastructures or fleet movements, only the occasional unexplained blip like Oumuamua, the interstellar visitor that defied easy categorization. Even our own planet's history offers clues. Indigenous cultures often failed to spot approaching ships until they were inches from shore, their minds unable to process something so far outside their experience. Could we be making the same mistake on a galactic scale? The paradox deepens when you consider time. Civilizations might rise and fall in cosmic eye blinks, their signals fading before overlapping with ours. Imagine two fireflies in a vast meadow, flashing just once, centuries apart. They'd never know the other existed, or perhaps we're simply too early, with the first wave of intelligence still brewing in distant oceans and gas giants. The universe is young. 95% of all stars that will ever exist haven't even been born yet. But here's the twist: the greatest illusion might not be how aliens hide from us, but how we've misunderstood the nature of life itself. What if intelligence isn't a pinnacle but a fluke, or so rare that we're effectively alone? Or conversely, what if it's so common that it's boring, with civilizations evolving past the need to colonize or communicate, retreating into inner worlds of virtual bliss? The silence could be a mirror reflecting back our own assumptions about what life should look like. One thing's certain: the universe loves a good magic trick. Whether it's hiding civilizations in plain sight or whispering that we're truly the only ones here, the answer will force us to rethink everything, not just about aliens, but about our own fragile place in the cosmic dark. What if everything, every star, every atom, even your own thoughts, was just lines of code in some unfathomable supercomputer? The simulated universe hypothesis isn't science fiction anymore. It's a serious debate among physicists and philosophers. Think of it like this: if advanced civilizations could one day create hyper-realistic simulations of their ancestors, there'd statistically be far more simulated minds than biological ones. That means the odds where the original, real version become vanishingly small. Even glitches we blame on quantum uncertainty or dark matter might just be processing errors, cosmic buffering in a universe-sized rendering engine. Take the speed of light, for example. It's not just a limit, it's the processing speed of reality itself, the maximum rate information can travel through the simulation. Quantum entanglement's spooky action, that could be two variables sharing the same memory address, updating instantly no matter how far apart they appear. And dark energy's mysterious push might be the universe's rendered distance expanding, allocating more memory as the program runs. The creepiest evidence comes from pure math. Our universe's physical constants are suspiciously fine-tuned for life. Adjust gravity by 1%, and stars wouldn't form. Coincidence or the signature of a programmer tweaking the parameters? Even the pixelation of reality fits. At the Planck scale, space and time become grainy, like the resolution limit of a digital display. Critics argue this idea is unfalsifiable, a cosmic shrug that explains nothing. But proponents counter that if this is a simulation, there might be cracks in the facade. Particle physicists sometimes detect odd energy fluctuations that defy explanation, like background noise in the code. Others hunt for repeating patterns in cosmic rays, potential signatures of underlying computational processes. One team even proposed that if the simulation uses a lattice to model space, high-energy particles would travel slightly differently along its axis, a faint anisotropy we might spot. Whether metaphor or reality, the simulation hypothesis forces a profound question. Does it matter? If this is a construct, every experience, every emotion still feels real to us, the ultimate virtual reality with no off switch. And if some advanced beings are watching, perhaps we're not just their ancestors in a historical sim, but something far stranger, an art project, a thought experiment, or even a cosmic game hiding its true rules just beyond our reach. Time isn't the rigid, unchanging river we imagine. It's more like a stretchable fabric warping under the weight of the universe itself. Picture two identical clocks, one placed on a mountaintop, the other deep in a valley. After a few years, the higher clock runs slightly faster. Not because it's defective, but because Earth's gravity tugs harder on the valley clock, slowing time itself in a phenomenon called gravitational time dilation. This isn't science fiction, it's a daily reality for GPS satellites. Orbiting 12,000 miles above us, their atomic clocks gain about 45 microseconds every day, a tiny difference that would throw off your phone's navigation by miles if engineers didn't account for it. The effects grow stranger near cosmic monsters like black holes. If you could hover just outside the event horizon, where gravity is so strong even light can't escape time, for you would crawl compared to someone watching from a safe distance. To them, your movements would appear to freeze, your signals stretching into an infinite redshift. Yet for you, time would pass normally, a cruel trick of relativity that means the universe's most dramatic events might play out in slow-mo for distant observers. It's as if space-time itself becomes a funhouse mirror, distorting not just space but the very flow of cause and effect. And it's not just gravity that warps time, speed does too. The faster you travel, the more time slows down relative to those at rest. Astronauts aboard the International Space Station, zipping around Earth at 17,000 miles per hour, age ever so slightly slower than people on the ground. Over a 6-month mission, the difference amounts to just a few milliseconds, but push the limits further, and the effect becomes staggering. A theoretical spaceship flying at 99% the speed of light could cross the galaxy in what feels like 20 years to its crew, while back on Earth, tens of thousands of years would pass. The travelers wouldn't just venture across space, they'd leapfrog through epochs, returning to a world unrecognizable. What makes this truly mind-bending is that there's no master clock ticking away in the background. Every observer's experience of time is equally valid, a concept that shatters our intuitive notion of a universal now. Two events that appear simultaneous to you might happen in sequence for someone moving at a different speed, or even in reverse order under extreme conditions. The past, present, and future aren't fixed points but fluid possibilities, woven together by the unique perspective of each observer. This relativity of reality might explain one of the universe's greatest magic tricks, how it keeps its deepest secrets hidden in plain sight. Time isn't just a dimension we move through, it's an active participant bending, stretching, and twisting to conceal the true nature of existence. From the infinitesimal corrections in your phone's GPS to the frozen screams of light at a black hole's edge, these distortions are the universe's way of reminding us what we perceive as reality is just one thread in a far grander, far stranger tapestry. What if our universe is merely one page in an infinite cosmic library, with countless other versions of reality shelved alongside it? This is the spine-tingling premise of multiverse theory, the notion that existence isn't a singular phenomenon but a sprawling tapestry of parallel worlds. Picture a soap bubble floating in a dense foam, each fragile sphere containing its own unique physics, stars, and even versions of you. Some might have gravity 10 times stronger, snuffing out star formation before life could emerge. Others could harbor exotic particles that make dark matter seem mundane, and in a vanishingly rare few, conditions might align perfectly for civilizations to arise, asking the same haunting question: are we alone? The math behind this idea isn't just speculative fiction. When cosmologists trace the Big Bang's aftermath using quantum field theory, they find equations that naturally spawn multiple universes like cosmic firecrackers. Inflation, the universe's explosive early growth spurt, could have created not just one bubble of spacetime, but an endless froth of them, forever drifting beyond our observational horizon. String theory takes it further, proposing hidden dimensions curled tighter than an atom, where alternate realities vibrate at different frequencies like notes on a cosmic piano. Evidence might be closer than we think. The cold spot in the cosmic microwave background, that eerie, super-cooled region spanning billions of light years, could be a bruise left by a collision with another universe. Meanwhile, quantum mechanics insists particles exist in multiple states until observed, prompting some to wonder, could every unmeasured outcome spawn a new timeline? It's a dizzying thought. Every choice you've ever made might have branched into another reality where the opposite happened. But the real revolution lies in how this reshapes our search for meaning. If infinite versions of Earth exist, then somewhere out there, a universe holds the answers to all our what-ifs. One where dinosaurs never went extinct, where the Library of Alexandria's flames were doused, or where you took that job offer across the country. The laws of physics in those realms might render life impossible, or nurture civilizations so advanced they've mastered interstellar travel while we're still chipping at firestones. Critics argue this is untestable metaphysics, a retreat from science into fantasy. Yet supporters counter that the multiverse could explain cosmic fine-tuning without invoking divine intervention. Why is gravity perfectly dialed for stars to form? Because in an infinite ensemble of universes, some inevitably hit the jackpot. It's the ultimate cosmic democracy, not one reality, but all possible realities, each with its own rules, its own secrets, its own way of hiding them. Whether metaphor or physical truth, the multiverse forces us to confront an electrifying possibility. The greatest illusion isn't just that the universe hides its secrets, it's that we've mistaken our tiny corner of existence for the whole stage. Beyond the veil of our perception, countless other dramas may be unfolding, their scripts written in laws we can't fathom, their actors unaware they're not the only show in town. The universe balances on an invisible tightrope, and we've been blissfully unaware of the abyss below. At the heart of this cosmic tightrope walk is the Higgs field, an unseen energy blanket stretching through every inch of space, giving particles their mass like molasses, slowing down swimming marbles. But there's a terrifying possibility. What if this field isn't in its lowest energy state? Imagine a boulder perched halfway down a hill, seemingly stable until one nudge sends it careening. If the Higgs field rolled down to a true vacuum state, it would unleash a bubble of annihilation expanding at light speed, rewriting physics itself as it goes. Stars, planets, even the atoms in your body would unravel in an instant, replaced by new rules so alien, they might not even allow matter as we know it. The most unsettling part, this bubble could already be growing right now in some distant corner of the cosmos. Because it would move at light speed, there'd be no warning, no flash, no shockwave, just an instant where existence as we understand it ceases. It's like living in a house where the walls could turn to smoke at any moment, with no way to know until it happens. Some theories suggest this might have already occurred elsewhere, wiping out entire swaths of the multiverse before we could blink. Yet here's the twist, the odds of such an event are vanishingly small. The Higgs field has likely been metastable for over 13 billion years, surviving cosmic collisions and extreme energies. But unlikely isn't impossible. Particle colliders like the Large Hadron Collider have briefly created conditions trillions of times hotter than the Sun's core, probing whether we're living in a false vacuum. So far, the field holds, but every experiment is like pressing on the cosmic tightrope, testing its strength. What makes vacuum decay so chilling isn't just the destruction, but the deception. The universe appears stable, predictable, governed by unchanging laws. Yet beneath that facade, there might be a fragility we're only beginning to comprehend. It's the ultimate magic trick, convincing us the show will go on forever, while hiding the fact that the curtain could drop at any moment without applause, without warning, just silence. Zoom in far enough on the fabric of reality, and the smooth geometry of space-time begins to break apart like shattered glass. At scales a trillion times smaller than an atom, the universe might not be the calm, predictable arena we imagine. Instead, it could be a bubbling cauldron of quantum foam, where tiny wormholes flicker in and out of existence like bubbles in boiling water. These aren't the stable cosmic tunnels of science fiction, but fleeting quantum fluctuations forming and vanishing in fractions of a second, warping the very notion of here and there. The idea stems from a strange marriage of quantum mechanics and gravity. Normally, these two theories refuse to play nice. Gravity sculpts the large-scale universe, while quantum rules govern the subatomic world. But in the froth of quantum foam, their clash becomes impossible to ignore. Here, space-time isn't just bent, it's pulsing, churning with virtual particles that borrow energy from nothingness, exist for a heartbeat, then vanish back into the void. These brief disturbances twist space-time into knots so tight, they could momentarily puncture it, creating micro-wormholes smaller than a proton. For an instant, two distant points in the universe might touch, only to snap apart before anything could pass through. The wildest part, some physicists speculate these wormholes might be more than cosmic static. Under the right conditions, perhaps with an infusion of exotic matter or negative energy, a quantum foam wormhole could theoretically be stretched, stabilized, and turned into a traversable shortcut. Picture a ship threading the eye of a gravitational needle, emerging light years away in the time it takes to blink. It would be the ultimate cosmic cheat code, bending the speed of light rule without breaking it. Even stranger, these hidden passages might already be woven into the fabric of reality, waiting to be unlocked, like finding secret doorways in a house you've lived in for years. Yet the foam's elusiveness is its greatest trick. Probing such tiny scales requires energies beyond anything our particle colliders can muster, leaving the theory suspended between math and reality. Some researchers hunt for indirect clues, subtle anomalies in high-energy cosmic rays, or telltale distortions in the light from distant quasars that might have passed through foamy spacetime. Others suggest that if wormholes really pepper the quantum foam, they could leave fingerprints in gravitational wave data, tiny ripples betraying their ghostly presence. Whether the foam is a mathematical quirk or the foundation of reality itself, one thing's clear: the universe loves playing hide and seek. Just when we think we've mapped its rules, it reveals another layer of chaos beneath the surface, a reminder that even empty space is never truly empty, and stillness is just an illusion hiding infinite motion. If black holes are the universe's bottomless drains, white holes would be its fire hoses blasting matter outward with unstoppable force. These hypothetical cosmic geysers flip the script on everything we know about spacetime. While black holes trap light behind an event horizon, white holes would repel it, creating an impenetrable barrier where nothing can enter, only escape. Imagine throwing a rock at a waterfall's cascading torrent. No matter how hard you hurl it, the water's push sends it right back. That's the defiant nature of a white hole, a region of space where the universe itself seems to say, no entry. The math behind these enigmatic objects traces back to Einstein's equations. Just as black holes emerge as solutions to general relativity, so too do white holes' mathematical mirror images where time runs backward. Some theorists propose they could be the opposite end of a black hole's tunnel, spewing matter into another universe like a cosmic umbilical cord. Picture a black hole in our cosmos funneling matter through a wormhole, only for it to erupt from a white hole in another reality. It's a tantalizing idea, the ultimate recycling program where universes exchange material through hidden backdoors. Yet the universe loves to tease us with possibilities while withholding proof. No confirmed white hole has ever been observed, and for good reason. Their very nature makes them fleeting. Unlike black holes, which can feast on interstellar gas for eons, white holes would hemorrhage energy, evaporating or collapsing into black holes almost instantly. But what if we've been looking for them all wrong? Some astronomers speculate that certain ultra-high-energy cosmic rays or inexplicable gamma-ray bursts could be dying white holes' final screams. Others suggest the Big Bang itself might have been a primordial white hole, birthing our universe in a single explosive act, the most mind-bending implication. If white holes exist, they'd challenge our understanding of cause and effect. Time's arrow might not be absolute. A black hole's future could become a white hole's past, stitching together timelines in ways that defy intuition. It's as if the universe folded the rules of physics into a Möbius strip, where cause and consequence loop back on themselves. Whether cosmic myth or hidden reality, white holes remind us that the universe's greatest tricks might still be waiting in the wings. They're the ultimate cosmic escape artists. If they're out there at all, they've mastered the art of the vanishing act. Step into a room lined with mirrors, and reality starts playing tricks on you, the same person reflected endlessly, each copy seeming just as real as the original. Now imagine that effect stretched across the cosmos, where the stars, planets, and even your own hands might not be what they seem. This is the holographic principle, a theory so radical it suggests our three-dimensional universe could be nothing more than a projection, like light beaming from a movie screen. According to this mind-bending idea, all the information that makes up reality, every galaxy, every atom, every fleeting thought, might actually be encoded on a two-dimensional surface at the very edge of existence. We're not just observing a hologram, we might be the hologram. The roots of this idea trace back to an unexpected place, black holes. When physicists calculated how information behaves at a black hole's event horizon, they stumbled upon a paradox. According to quantum mechanics, information can never be destroyed, yet black holes seemingly erase whatever falls in. The solution, the information isn't lost, it's smeared across the horizon's surface like data etched onto a cosmic hard drive. Take this logic further, and the entire universe starts to look like a black hole's horizon writ large, a vast, flat canvas where the script for reality is written, with our 3D world as its shimmering projection. Here's where it gets even stranger. If the holographic principle holds, the universe isn't just like a hologram, it fundamentally is one. The chair you're sitting on, the screen in front of you, all of it would be a kind of optical illusion, pixels rendered by underlying data we can't perceive. Think of it as nature's ultimate sleight of hand, where the depth, texture, and solidity of everything around us are just clever tricks played by a deeper, flatter reality. Even time itself might be part of the illusion, a narrative structure our brains impose on a universe that, at its core, operates without it. Evidence for this cosmic magic act is still tentative but tantalizing. Certain quantum gravity models suggest spacetime might be pixelated at the tiniest scales, like a digital image revealing its graininess when zoomed in too far. Other clues come from the cosmic microwave background, where some physicists hunt for anomalies, subtle fingerprints that might betray the universe's true two-dimensional origins. And then there's the ADS/CFT correspondence, a mathematical framework that bridges theories of gravity in 3D with quantum theories on a 2D surface, offering a blueprint for how such a holographic universe might operate. But the most unsettling implication isn't just about physics, it's about perception. If the holographic principle is correct, then free will, consciousness, even the passage of time could be emergent phenomena, side effects of a deeper computational process we're only beginning to decode. It's as if we've spent centuries studying the shadows in Plato's cave, unaware that the real action is happening behind us, on a wall we haven't even thought to turn toward. Whether metaphor or fundamental truth, the holographic principle forces us to confront a humbling possibility. The universe's greatest trick might not be hiding its secrets in distant galaxies or dark matter, but in the very nature of reality itself, convincing us it's solid, spacious, and three-dimensional when, in fact, it could all be unfolding on a flat, cosmic stage just beyond the edge. Sight, hold out your hand right now. A blizzard of cosmic phantoms is slicing through it like you're made of smoke. Neutrinos, the universe's most elusive particles, pour through your body at nearly the speed of light, over 100 trillion every second, leaving no trace behind. Born in the nuclear furnaces of stars, the violent deaths of supernova, and even the radioactive decay of rocks beneath your feet, these shadowy particles have one defining trait: they barely acknowledge the existence of matter. A neutrino could pass through a light year of solid lead over 6 trillion miles without a single collision. It's as if the universe whispered its secrets in a language most of reality can't hear. Catching these phantoms requires feats of engineering that border on madness. Take Japan's Super Kamiok and a detector buried deep inside a zinc mine filled with 50,000 tons of ultra-pure water. When the rare neutrino does interact, it creates a fleeting spark of blue light Cherenkov radiation captured by thousands of sensitive phototubes lining the walls. It's like trying to photograph a bullet by waiting for the 1 in a trillion chance it grazes a feather mid-flight. Yet these detectors have unlocked astonishing truths. Neutrinos from supernova 1987 arrived hours before the exploding star's light, giving us our first glimpse of a dying star's core collapse in real time. But the real shock came when scientists realized neutrinos refused to play by the expected rules. Oscillating between 3 flavors as they travel: electron, muon, and tau, they proved they have mass appending the standard model of particle physics. This tiny wobble, discovered by observing neutrinos that seemingly vanished en route from nuclear reactors to detectors, revealed a hidden layer of quantum behavior. Even more bizarre are sterile neutrinos' hypothetical 4th flavors that might interact only through gravity, making them potential dark matter candidates. What makes these phantoms so tantalizing is where they've been. Solar neutrinos carry whispers from the sun's core, unaltered by the 100,000-year journey through its plasma. High-energy ones, dubbed cosmic neutrinos, point back to violent events like black hole jets or colliding neutron stars, offering a pristine view of the universe's most chaotic corners. And relic neutrinos from the Big Bang, cooled to near absolute zero, might still ripple through space, a fossilized echo of creation itself. Yet for all their abundance, neutrinos guard their secrets fiercely. They could hold clues to why the universe favors matter over antimatter, or how stars heavier than 30 suns collapse into black holes without a visible supernova. Some theories even suggest they're entangled with dark energy, their tiny masses shaping the cosmos's expansion. Every detection peels back another layer of their mystery, reminding us that the universe doesn't just hide its secrets in distant galaxies, it threads them through our very bodies, silent and unseen, waiting for us to listen. One moment, space is silent; the next, a blast of radio waves brighter than 1 billion suns screams across the cosmos, only to vanish without a trace. Fast radio bursts are the universe's most baffling fireworks, fleeting signals that pack more energy in a millisecond than our sun emits in 3 days. First discovered in 2007, these bursts arrive without warning, some from billions of light years away, their sources hidden behind a veil of cosmic static. What makes them even stranger is their split personality. Most are loners, flashing once and disappearing forever, while a handful repeat like clockwork, teasing astronomers with clues they can't quite decipher. Take FRB 121102, the first repeating burst ever detected. Nestled in a dwarf galaxy 3 billion light-years away, it's spat out hundreds of bursts since its discovery, some separated by mere minutes, others by months. Then there's FRB 200428, which left an unmistakable fingerprint, a burst so powerful it was traced back to a known magnetar in our own galactic backyard, proving at least some of these signals come from highly magnetic, spinning neutron stars. But here's the catch: most bursts don't have such convenient explanations. Their sheer power and variety suggest multiple origins, from colliding neutron stars to evaporating black holes or even cosmic strings, hypothetical defects in spacetime itself. The real puzzle lies in their journey. As these bursts traverse the cosmos, they interact with the sparse atoms between galaxies, slowing slightly in ways that reveal the universe's hidden matter. It's like listening to a song played through a dense forest. The way the sound changes tells you about the trees it passed through, even if you can't see them. This makes fast radio bursts cosmic probes, helping map the elusive web of gas and dark matter that binds the universe together. But the most electrifying theory: these bursts could be artificial. Imagine a civilization so advanced it harnesses the energy of stars to power interstellar beacons, or perhaps uses colossal light sails propelled by radio waves, accidentally leaking pulses into the void. While natural explanations are far more likely, the possibility lingers, a whisper that we might not be the only ones listening. For now, every new detection deepens the mystery. Some bursts arrive with a twist. Their radio waves spiral like corkscrews, hinting at extreme magnetic fields. Others come with X-ray counterparts, suggesting violent origins. With each flash, astronomers race to triangulate their sources, building a cosmic census of these enigmatic signals. Whether stellar catastrophes, exotic physics, or something even stranger, fast radio bursts remind us that the universe loves to flirt with the unexplained, offering just enough light to reveal how much darkness still hides beyond our gaze. On October 19, 2017, astronomers spotted something streaking through our solar system that shouldn't have been there, a visitor from another star. Named Oumuamua, Hawaiian for scout or messenger, this strange, tumbling object defied every expectation. Most asteroids and comets follow predictable paths shaped by gravity and sunlight. But Oumuamua accelerated as it raced away from the sun, as if some unseen force were pushing it. The first interstellar object ever detected wasn't just passing through, it was showing off. At first glance, its shape alone was bizarre, roughly 10 times longer than it was wide, tumbling end over end like a cosmic cigar. Nothing in our solar system looks quite like it. Then came the real puzzle. Its acceleration couldn't be explained by gravity alone. Comets often speed up slightly as ices on their surface vaporize, creating a faint jetting effect. But Oumuamua showed no visible tail, no gas cloud, no dusty debris. It was as if it had an invisible engine, gently thrusting it forward without leaving a trace. Theories erupted like supernova. Some scientists proposed it was a rare hydrogen iceberg, its surface vaporizing in sunlight too subtly for our telescopes to catch. Others suggested it might be a porous, fractal-like dust aggregate, a celestial snowflake sculpted by unknown processes in another star system. Then there was the more provocative idea: what if it wasn't natural at all? The absence of outgassing, combined with its peculiar shape, led a few researchers to speculate cautiously about an artificial origin. Could it be a light sail, a fragment of alien technology drifting between the stars? But Oumuamua wasn't done weaving illusions. As it hurtled beyond the reach of our telescopes, its true composition remained veiled. Was it rocky, metallic? An icy relic from another planetary system, the data was maddeningly sparse, like trying to reconstruct a novel from a single torn page. Even its size is uncertain. Estimates range from a football field to half a mile long, depending on how reflective its surface really was. The greatest trick Oumuamua pulled, it vanished before we could truly know it. By the time we spotted it, the object was already on its way out, leaving behind a trail of theories but no concrete answers. Future interstellar visitors might shed light on the mystery, but for now, Oumuamua remains a cosmic enigma, a silent messenger from the void, hinting at wonders and oddities lurking in the darkness between stars. Galaxies might seem like serene islands of stars floating through the void, but beneath that tranquil facade, they're engaged in a slow-motion feeding frenzy. Our own Milky Way is no exception right now. It's quietly devouring its neighbors, stretching their stars into ghostly streams that wrap around us like cosmic spider silk. The Sagittarius dwarf galaxy is one such victim, a tiny companion being torn apart by our galaxy's gravity. Its stars scattered across the sky in an arc so faint, it went undiscovered until the 1990s. This isn't some rare cosmic event, it's how galaxies grow. Over billions of years, the largest galaxies feast on smaller ones, absorbing their stars, gas, and even dark matter, growing heavier with every silent merger. The evidence is written in the stars themselves. Telescopes have spotted these stellar fossils, long, looping ribbons of stars that shouldn't orbit the Milky Way so neatly unless they were the shredded remains of a devoured galaxy. One of the most famous, the Gaia sausage, is the mangled core of a dwarf galaxy that collided with ours over 8 billion years ago. Its stars now move in odd radial orbits, like bees trapped in a jar, their paths forever marked by that ancient violence. Even our galaxy's outer halo, once thought to be a placid sea of old stars, is now known to be a graveyard of cannibalized galaxies, their identities erased but their stars still whispering of past cataclysms. And the Milky Way isn't alone in this celestial feast. The Andromeda Galaxy, our nearest spiral neighbor, shows even clearer scars of its predatory past. Its outer disk is warped and studded with odd clusters of stars leftovers from smaller galaxies it's absorbed. Some computer models suggest Andromeda's entire structure might be the result of a colossal collision billions of years ago, a merger so massive it reshaped the galaxy into the giant we see today. But the ultimate display of galactic cannibalism lies in the hearts of galaxy clusters. There, monstrous ellipticals like Messier 87 lurk, having gorged on hundreds of smaller galaxies over eons. These giants swell to incomprehensible sizes, their gravity so strong they can pull in entire galaxies from across millions of light years. The process isn't quick or flashy. It's a slow, inexorable tug of war that can take billions of years, leaving behind trails of orphaned stars and orphaned black holes, all swallowed into the belly of a cosmic titan. Yet for all its violence, this hidden dance of mergers and acquisitions has a strange beauty. Without it, galaxies wouldn't evolve, stars wouldn't recycle, and the universe would lack the diversity of structures we see today. The Milky Way itself is a living archive of these ancient meals, each digested galaxy adding to its mass and complexity. And one day, far in the future, even our galaxy won't be the predator, but the prey, as Andromeda barrels toward us for a collision that will reshape both into something entirely new. The universe doesn't just hide its secrets in darkness or distance, it buries them in the slow, silent feast that built everything we see. The cosmic microwave background should look like a splatter of random noise, a perfectly uniform spread of hot and cold spots from the Big Bang's afterglow. But when scientists mapped it in detail, they stumbled on something downright eerie. The fluctuations aren't random at all. Instead, they're weirdly aligned along a particular axis, like invisible brushstrokes painted across the sky. Astronomers call it the axis of evil, partly as a joke about its defiance of cosmic expectations, and partly because it threatens to unravel one of cosmology's core principles. This mysterious axis isn't just a minor quirk. It points toward a universe that might not be the same in all directions, shattering the assumption of isotropy, the idea that space looks identical no matter where or how you gaze into it. Imagine spinning a globe and realizing the continents always line up along one invisible line, no matter how you tilt it. That's how unsettling this alignment is for physicists. It's as if the universe has a preferred direction, a cosmic north that shouldn't exist according to the standard model. So what could be causing this celestial conspiracy? One possibility is that we're seeing the fingerprints of something beyond our observable universe, like a gravitational tug from a neighboring bubble universe brushing against ours in the multiverse's foam. Alternatively, the early universe might have rotated, imprinting a spin on spacetime itself that lingers in the microwave background like a fossilized whirlpool. Even stranger, some theorists suggest dark energy could be unevenly distributed, stretching space more in one direction than another, warping the cosmos into a lopsided shape we're only now detecting. But skeptics argue it could all be a grand illusion, a trick of statistics, or an artifact of how we filter noise from the data. After all, the human brain is wired to find patterns even where none exist. Yet the axis has stubbornly resisted dismissal. Every new map of the cosmic microwave background, from WMAP to Planck, keeps revealing the same eerie alignment, defying the odds of a mere coincidence. If this axis is real, the implications are staggering. It could mean the Big Bang wasn't perfectly symmetrical, or that our universe is caught in something larger, like a leaf floating in a hidden current. For now, the axis of evil remains one of cosmology's most tantalizing loose threads, a whisper that the universe might be playing by rules we haven't even imagined yet. Something out there is tugging at the solar system's edge, a phantom so massive, it warps the paths of distant objects like an unseen puppeteer. Beyond Neptune, in the icy expanse of the Kuiper Belt, dozens of small worlds follow bizarre, clustered orbits that defy explanation. These frozen bodies shouldn't all tilt the same way or bunch together as they do, unless something huge is herding them. Enter Planet 9, a hypothetical giant possibly 10 times Earth's mass, lurking so far from the Sun that a single orbit could take 20,000 years. Finding this cosmic hide-and-seek champion is no easy feat. At an estimated distance of 20 times farther than Neptune, sunlight reaching Planet 9 would be so faint, spotting it would be like searching for a single street lamp in a blizzard across half the planet. Even our most powerful telescopes struggle to pierce that gloom, scanning slivers of sky in hopes of catching a pixel that moves against the starry backdrop. Yet the gravitational clues are undeniable. objects like Sedna and 2015 BP 519, a Kuiper belt resident with an orbit tilted a staggering 54 degrees, shouldn't exist without a massive disruptor sculpting their paths over eons. Theories about Planet Nine's origins read like cosmic heist plots. It might be an exiled ice giant hurled outward during the solar system's chaotic youth when Jupiter and Saturn's gravity played planetary pinball. Or perhaps it's a rogue world captured from another star, trapped by the sun's pull long ago. If real, its discovery would rewrite our solar system's story, revealing how dynamic and violent our neighborhood truly was and how much we've missed. But skeptics argue the odd orbits could result from collective gravitational nudges among smaller objects, or even a statistical fluke in our limited observations. Others propose a primordial black hole, no larger than a grapefruit but as massive as 10 Earths, could explain the anomalies without a planet at all. The hunt continues, with astronomers methodically ruling out patches of sky, while upcoming telescopes like the Vera Rubin Observatory could finally spot the culprit. Whether phantom planet or something stranger, the mystery underscores a humbling truth. Even in our own cosmic backyard, the universe loves to keep secrets. We've mapped every corner of the solar system, or so we thought, only to find its edges whispering of giants still unseen. What if some particles don't just break the speed limit, they're born speeding? Tachyons, the universe's hypothetical speed demons, exist only in the realm of theory, but their implications are so staggering they've haunted physicists for decades. Unlike everything else in the known cosmos, these phantoms wouldn't just approach light speed, they'd start faster than light, their very existence flipping our understanding of cause and effect on its head. Picture this: while ordinary particles need infinite energy to reach light speed, a cosmic barrier enforced by Einstein's relativity, tachyons would find it impossible to slow down to that speed. Their energy would drop as they accelerated, turning physics textbooks into kindling. Stranger still, according to relativity's equations, a tachyon moving faster than light would appear to an observer as rewinding through time. A signal sent via tachyons could arrive before it was emitted, like a letter reaching you before it's dropped in the mailbox. But why even entertain such a dizzying idea? Tachyons first emerged as mathematical quirks in particle physics, solutions to equations that scientists initially dismissed as impossible. Yet over time, their theoretical utility grew. Some models of the early universe suggest tachyons might have played a role in triggering cosmic inflation, that explosive expansion moments after the Big Bang. Others propose they could be the hidden scaffolding of spacetime itself, fleeting disturbances in quantum fields we've yet to detect. The real controversy lies in their causality-smashing potential. If tachyons exist, they'd open the door to time paradoxes, messages altering their own past, effects preceding causes, realities where history rewrites itself on the fly. To avoid this, physicists have proposed self-consistent models where tachyon interactions cancel out any logical contradictions, like a cosmic spell checker ensuring the timeline stays intact. Despite decades of searching, from scrutinizing cosmic rays to hunting for anomalous energy patterns in particle colliders, tachyons remain stubbornly undetected. Some argue their absence proves they're mere mathematical ghosts, but others counter that we might be looking for them all wrong. If tachyons interact only weakly with ordinary matter, they could be streaming through us right now, as unnoticed as neutrinos before we knew how to catch them. Whether cosmic reality or elegant fiction, tachyons challenge us to imagine a universe far stranger than the one we think we know. They remind us that light speed, causality, even time itself might not be the rigid boundaries we assume, but mere signposts in a much weirder, wilder cosmos still hiding its true rules. Consider the odds given infinite time and space. Even the most impossible events become inevitable. That's the terrifying premise behind Boltzmann brains, a thought experiment so unsettling it makes the Matrix seem like child's play. Named after physicist Ludwig Boltzmann, the idea suggests that in a chaotic, eternal universe, self-aware consciousness could spontaneously flicker into existence from random quantum fluctuations. A lone brain, complete with false memories, floating in the void, convinced it's living in a real world. These cosmic accidents would outnumber genuine, biologically evolved minds by an unimaginable margin, raising a chilling question: what if you're one of them? The math is deceptively simple. In a universe governed by entropy where disorder reigns, tiny pockets of order can still emerge by chance, like a gust of wind assembling a sandcastle. Given enough time, even something as complex as a thinking mind could, theoretically, assemble itself from pure chaos. A Boltzmann brain wouldn't need a body, a planet, or even a star. It would just wake up, armed with fabricated memories of a past that never happened, a present that doesn't exist, and a future it will never have, the ultimate cosmic prank. But here's where it gets even stranger. If Boltzmann brains are possible, they'd eventually outnumber real observers like us by trillions to one. Statistically, the odds that your consciousness is the product of a stable, ordered universe rather than a random fluctuation become vanishingly small. It's like being dealt a royal flush in poker 1,000,000 times in a row and insisting it's just luck. The universe, it seems, might be hiding its true, chaotic nature behind our fleeting illusion of order. Physicists have scrambled to debunk this nightmare scenario. Some argue that our universe's expansion and finite lifespan make Boltzmann brains impossible. There simply hasn't been enough time for such unlikely events to occur. Others point to quantum field theory, suggesting that the vacuum of space doesn't permit stable, self-aware fluctuations. Then there's the most pragmatic rebuttal. If we were Boltzmann brains, reality would likely glitch, memories would contradict, physics would be inconsistent, and the illusion would shatter. Yet here we are, sipping coffee, remembering yesterday, and trusting that the sun will rise tomorrow. But the real sting of the Boltzmann brain paradox isn't just about our own existence. It's a warning about how little we truly understand the cosmos. If even our sense of self could be a quantum mirage, what else might the universe be hiding? The answer, perhaps, is the most unsettling illusion of all, that we've ever had a firm grasp on reality to begin with. Imagine throwing a book into a fire. The pages blacken, the ink fades, but in principle, if you tracked every ash particle and wisp of smoke, you could reconstruct every word. That's the core promise of quantum mechanics. Information is never truly destroyed, only scrambled. Now picture tossing that same book into a black hole. According to Einstein's theory, it's gone forever, crushed into a singularity where not even light escapes. This clash between quantum immortality and gravitational oblivion is the black hole information paradox, a puzzle so profound it's divided physicists for decades. At first glance, the paradox seems simple. When matter vanishes behind an event horizon, it takes its quantum information, spin, charge, particle type with it, violating quantum theory's sacred rule of reversibility. But in the 1970s, Stephen Hawking made things worse. He showed black holes aren't completely black, they slowly leak energy, now called Hawking radiation. Here's the twist: this radiation appears totally random, carrying no trace of what fell in. If the whole eventually evaporates, leaving only this thermal static, where did the original information go? One daring solution comes from the holographic principle. Just as a 3D hologram is encoded on a 2D surface, maybe all the information swallowed by a black hole gets smeared across its event horizon like cosmic graffiti. In this view, the horizon isn't just a point of no return, it's a frenzied quantum hard drive storing data in Planck-sized pixels. When Hawking radiation escapes, it might subtly carry imprints of that scrambled information, like smoke carrying traces of the burned book's ink. Then there's the firewall hypothesis, a cosmic horror show where the event horizon isn't smooth but a searing wall of energy. As particles approach, they'd be incinerated, their information converted into radiation immediately. It solves the paradox by preventing anything from truly entering the black hole, but at the cost of violating relativity's prediction that crossing the horizon should feel uneventful. The wildest idea, maybe information doesn't disappear at all. Wormholes could thread through black holes, connecting their interiors to other regions of spacetime. What looks like annihilation from the outside might be teleportation, with data emerging somewhere else entirely, perhaps in a baby universe branching off from our own. It's as if the cosmos has a secret backdoor for information, ensuring nothing is ever truly lost, just relocated beyond our sight. Yet the paradox lingers because each solution demands rewriting physics as we know it. The holographic principle challenges our notion of spatial dimensions. Firewalls pit quantum mechanics against Einstein's gravity. Wormholes flirt with science fiction. Whatever the answer, one thing's certain. Black holes aren't just cosmic trash compactors, they're Rosetta Stones, hiding the key to how the universe encodes, preserves, and perhaps even transcends the very fabric of reality. Time doesn't always move forward, sometimes it dances in place. Time crystals are the universe's way of bending its own rules, structures that pulse in perfect rhythm without energy input, like a pendulum that never slows. Unlike ordinary crystals where atoms arrange in repeating spatial patterns, time crystals tick through cycles in time itself, resetting their quantum states with clockwork precision. Imagine a snowflake that melts and refreezes endlessly, not because of temperature changes, but because that's simply how it exists, a paradox made real in labs cooled to near absolute zero. The first experimental time crystals, created in 2016, defied expectations. Scientists used chains of ytterbium atoms, zapping them with lasers to kickstart a rhythm independent of external energy. The result, a quantum metronome that couldn't settle into equilibrium, forever oscillating between states. This wasn't just a scientific curiosity, it shattered the long-held assumption that all systems must eventually reach stillness. Time crystals don't just resist entropy, they laugh at it, weaving order from the fabric of time without permission. But here's the twist, nature might have beaten us to it. Deep inside neutron stars, where matter is crushed into exotic quantum soups or tangled in the vortices of superfluid helium, natural time crystals could already be ticking away, hidden in plain sight. Some theories even suggest dark matter could form crystalline structures in time, clumping into rhythms that span eons. If true, these cosmic clocks would operate on scales we've barely begun to fathom, their pulses so slow or so fast they've escaped detection. The implications rewrite physics at its roots. Time crystals hint at a layer of reality where temporal symmetry, the idea that physical laws stay constant over time, isn't just broken but reinvented. They could unlock new forms of quantum memory, where information is stored in loops of time rather than static bits. Or they might reveal pathways to control entropy itself, bending the arrow of time to our will. For now, these possibilities linger at the edge of theory, whispers of a universe where time isn't a river but a spiral, folding back on itself in ways we're only beginning to trace. The universe doesn't just hide its secrets, it performs them, an endless magic show where every reveal only deepens the mystery. What we perceive as reality is a carefully constructed illusion, with light bending to conceal cosmic giants, time stretching to obscure the past, and dimensions folding to hide entire layers of existence. Dark matter's gravitational whispers, quantum entanglement's eerie synchronicity, even the holographic suggestion that we're all projections of a flat, distant surface. each discovery peels back another veil, exposing how little we truly grasp. Consider how effortlessly the cosmos deceives us. Stars that died millennia ago still wink in our night sky, their light a posthumous farewell. Black holes cloak themselves behind event horizons, their crushing depths invisible until matter screams its death throes in X-rays. And dark energy, that enigmatic force accelerating the universe's expansion, works in the shadows, its effects undeniable yet its nature utterly unknown. These aren't just gaps in our knowledge, they're deliberate feints, as if the universe delights in keeping us guessing. Yet the greatest trick might be how these illusions propel us forward. Every paradox, every unexplained anomaly is a breadcrumb trail leading to deeper truths. The holographic principle emerged from black hole physics. Dark matter's fingerprints were found in the warped light of galaxy clusters. Even the unsettling axis of evil in the cosmic microwave background hints at cosmic structures or laws we've yet to imagine. The universe doesn't just conceal, it beckons, daring us to look closer, think stranger. So the next time you step outside and gaze upward, remember, the sky is a stage and reality is the magician. Those twinkling stars, their performances from the past. The empty black between them, a canvas teeming with dark matter and hidden forces. What feels solid, predictable, known, it's all part of the act, and the best part. We've only just been handed the program. If this journey through cosmic sleight of hand left you questioning what's real, you're not alone. Hit like if you're ready for more mind-bending revelations. Subscribe to join us as we decode the universe's next great illusion, and drop a comment below. What cosmic mystery keeps you up at night? The curtain's rising on an even stranger encore, and trust us, you won't want to miss it. The universe has plenty more tricks up its sleeve.